Here we're going to look at another example of perimeter and array, and this time this is a challenge. So assume that you're given a task to pack as many identical circles as possible in a square. The square has side length of 20 and the circles have radii of 1. And the circles cannot be overlapping and cut. What is the maximum possible number of circles that you can pack into the square? And what sort of arrangement would you do to achieve this maximum possible number? And quickly note that this may or may not require the Pythagorean theorem, so just keep that in mind. As you may have known already, circles don't really fit in perfectly into squares, which means we cannot really just divide the area of the square with the area of one circle. Otherwise, we're afraid that if we have some space left with the circles, that space might be used for another circle, which then will break our rule of no cutting of circles. So let's see what kind of arrangement we can use. So one may suggest that we can just arrange them in a grid shape format, which means we can just arrange a number of circles horizontally and vertically. And furthermore, one can check that we can arrange 10 circles horizontally and 10 circles vertically, leaving a total of 100 circles. But that's not really the best that we can do. Notice that we can arrange the circles in a triangular format, or in other words, between two circles we can put one circle above it, and then after that we can put two more circles and one right there, and so on. Now the problem is that we don't really know how many layers of circles we're going to use. So first, let me indicate the centers of these circles, and let's just draw them so that it forms an equilateral triangle with side length of 2. Let me just draw a replica right here since the space there is too small. And notice that we can just find the height right here by the Pythagorean theorem. Notice that the height bisects the base, which will be 1, this will be 2. Therefore, the height will be square root of 3. We can suppose that n is the number of layers that we're going to use right here. We can form an equation in terms of n relating to the height we're going to need, or I should say an inequality. Notice that the space right here underneath the equilateral triangle is 1, and the space right above here will be also 1, after we're going to arrange them, of course. So the inequality will be as so. So 1 plus 1 will be 2, plus, notice that we're going to have n minus 1 square root of 3's appearing in our arrangement, and we need to set this less than or equal to 20, which is the side length of the square. Solving this inequality and finding the largest integer n that satisfies this gives us that n must be equal to 11. So then we have 11 layers. Next, notice that we have two types of layers of circles. One layer that gives us 10 circles and one layer that gives us 9 circles. And notice that it is repeating in a cyclic format. So we have the layer of 10, the layer of 9, the layer of 10, and the layer of 9, and so on. And also, one can check there are 6 layers with 10 circles and 5 layers with 9 circles, leaving us with a maximum number of circles be 105. Or so you thought it is 105. Notice that right here, after we arrange our circles, we're left with quite a large amount of space right here. And let's see if we can use that space for like at least one circle. And indeed we can, because notice that if we set this second upper layer into a layer with 10 circles, our maximum is not 105 but it is 106, and no other arrangement will give a larger amount of circles than 106, which ends this video.